Okay, let's look at this lemma. So this lemma says that let X be a set, let B be a basis for a topology T on X, then T equals the collection of all unions of elements of B. So this lemma says that if we have a new collection, it's the collection of all unions of elements of B. So this new collection we call it BU, and the elements of this collection we call them U, and those U are the all are any possible union of the basis element from the basis B. So U is a union of BI, and the BI should be the basis element from the basis, like this. So this means that the elements of this new collection are all the possible union of the basis element. And this lemma says that this new collection is actually the topology itself. It equals to the topology T. So this is very interesting because this new collection is made from the basis elements. We didn't put new elements into this collection. All the elements are made by the basis element. So that means that because this new collection is equal to the topology T, so it means the basis contains all the information required to build the topology T. Okay, now let's prove this lemma. So to prove this, because this is a relationship between two collections or two sets, so in order to prove two sets are equal to each other, we can one method is to prove the two sides of this equal sign are just a subset of each other. So it means that we can prove BU is a subset of T, and then we can prove T is a subset of U. Then we can say they equal to each other. Okay, so first let's prove this one. Why BU is a subset of T? Because this relationship is equivalent to, for example, we say U, like for any U from the BU, this U should be a element of T. So this relationship is equivalent to this one. So we only need to prove that the U is an element of T. And why this is true? Because for any U inside of the BU, the U is a union of BI, and BI are the basis element from basis. And because we know that BI are the basis element, so they should be the element of T. We have proved this before. So we have this relationship. And then how about the union of BI? The union of BI. So because according to the definition of topology, the union of any element of the topology should still be an element of the topology. So the union of the BI should still be an element of T. So this union should be element of T. And because this union is just the U itself, so this just proves that U is an element of T. So this the first relationship we have proved here. And then we should prove that T is actually a subset of BU. Okay, for this one, similarly, we can say that for any element T in the topology T, the T should also be an element of BU. Okay, so why this is true? Because what is T? T is an element of topology, so T should be an open set. T is open. And for open set, we have this relationship. So for for any element X in the open set T, we can find a basis. We call it BI, maybe for any XI from T. For this XI is contained in this BI, and this BI is a subset of the T. It is in T. So this relationship is true because we have proved here. So this is just how we determine if a set is open or not. So we have here for the open set, we can find for any element X in the open set, the X is inside a basis element B, and the B is a subset of the open set U. So this is true. And then what can we do is we do the union operation for this long relationship, to the union for this XI, to the union for this BI, and to the union for T. And the result is like this: the union of XI for all the XI in T. We union all the XI in T. And here, similarly, BI, we do the union of BI over all the all the XI, because for each XI we have a BI corresponding to it, so we can do this union. And also here we do the union of XI in T for this T. Okay, because the operation for those three things are the same, they are same union, so the relationship between them will be kept. So this will belong to this, and because this one before the union it is an element, and now because we do the union, so it becomes a set. So we should change the side from this to the subset side, and so now we have this relationship. And then let's look at this. So what is this first one? This if we do the union of all the elements in T, it is just the T itself, right? Because it contains all the elements of T. Okay, so we have T here, and for this we can't do too much more for it. So it's just like this. And for this, we do the union of, because no matter what XI is, this T is not changed. So the union of the union of multiple T's is just the T itself. So this is just the T. Okay, so here we can see the left side and the right side are T's. So we can say T is equal to this BI, the union of the BI, like this, right? Okay, so we have this relationship, and then we can say because the right side is the union of BI, and the union of BI, according to the definition of BU, this should be a subset, should be an element of this BU, like this. So it's like this. So we can say that we can conclude that T is an element of BU. Okay. So we proved this. The T is an element of BU. So then we prove this, and it means we prove this. And because we have those two relationship, then we can conclude that BU equals to T. Okay, that's why this is true. Okay, then we're done.